This is Algebra 1, Lesson 1-5, Equations. The objectives say, solve equations with one variable and solve equations with two variables. Vocabulary, open sentence, a mathematical statement with one or more variables. Equation, a mathematical sentence that contains an equals sign. Solving an open sentence. Finding a replacement value for the variable that results in a true sentence or an ordered pair when substituted into the equation. Solution, a replacement value for a variable in an open sentence. Replacement set, a set of numbers from which replacements for a variable may be chosen. And when you see a replacement set, it will be in these braces, which tells you it's a set. Element, each entry in a set. Solution set, the set of elements from the replacement set that makes an open sentence true. And when you write your answers as a solution set, you are going to use braces. Identity, an equation that is true for every value of the variable. Now let's go to the other side of your page to do example 1. Example 1 says to find the solution set for 4a plus 7 equals 23 if the replacement set is 2, 3, 4, 5, and 6. So if they give you a replacement set, you have to decide which of these elements would make this statement true. So you can try, I'm going to start with the first one, 4 times 2 plus 7 equals 23. Simplify, which we did with expressions on the left side. 4 plus 2 is 8. So we have 8 plus 7 is 23. Is this true? It is not, because 15 does not equal 23. So let's try another element. Let's say we try 4 from our replacement set. So we have 4 times 4 plus 7 equals 23. Let's see if this is true. 4 times 4 is 16. Is 16 plus 7 23? Yes, it is. So we chose the element 4 and it worked. Therefore, if we're answering the question, find the solution set, we're going to make our braces, and inside our set, we're going to put the element 4 because that one worked. Let's look at example 2. This one does not have replacement sets, but we have to solve for B. So let's look at what we have on the left side of our equation. This looks like an expression that we've simplified in the past. So let's do the order of operations. I see parentheses, and inside parentheses there's an exponent and subtraction. We need to do exponents first. So this simplifies to 8 minus 2. Bring the rest down. Continue simplifying inside your parentheses, and we have 6. And right here, it would be easy to add 3 and 4 and then multiply by 6, but you would be out of order if you did that. We have to multiply first. So 3 plus 24, and then simplifying your last step, and you would have 27. Now let's go on to example 3. This is similar to the last problem we had in that we have an expression, except it's on the right this time. So go ahead and simplify your expression. Start with parentheses first, and that would be 3. Bring down your 9 squared. And your next step would be to square your 9. Then you have 81 plus 3. Add those together, and you should get 84. And this equals t. And on the last problem, you do need to go ahead and bring down the b. I forgot to say that. Because we're working with equations now, bring down the b. If we were to put 27 into this equation, it would be equal. Now let's look at example 4. We have an expression on the left side of our equation that we need to simplify, and we have an expression on the right side of our equation that we need to simplify. So let's go ahead and get started. First of all, we need to do what's inside parentheses, so this becomes 14. If you would like to go ahead and move on to the other side, we can see that this one is simplified. You cannot combine these. So let's look at the right side. Inside parentheses, we would have a 4 and the n before it. And we can see that these are out of order because when we have a coefficient with a variable, the coefficient should come first. So we have 4n minus 9, and on the left side we have 4n minus 14. Both sides are simplified. Now we need to look at it. Is each side equal to each other? They are not. Since they are not the same on each side, then that means there's no solution. There is not any number that you can put into this equation that would make it true. If you put a 0 in here, it wouldn't make it true. If you put 500 in here, it wouldn't make it true. If you put -3, there's not any number to make this a true equation. Let's go on to example 5. Again, we have an expression on the left that needs to be simplified and an expression on the right that needs to be simplified. I'm going to start on the left. What would you do first? You would 8 divided by 4, which is 2, plus 3k. If you want to keep simplifying, then you would have 7 plus 3k. This is simplified. So I'm going to go on to the right side. First thing we need to do is parentheses. These two cannot be combined. There are no exponents. So then we move on to multiplication and division. Remember, distribution is multiplication. So when we distribute 3, we have 3k equals 96 minus 89. And this should not be equals. I should have brought down the plus sign. My equal sign actually goes here. Is this expression simplified? It is not. So let's keep going. We need to combine the 96 and the 89, and we get 7. Now we need to look and see, are these two equal to each other? Well, in addition, the commutative property says that we can switch around our terms and it would be the same. So if I switched around my terms on the left side, it would look exactly like what I have on the right side. Since they are exactly equal, this is what our definition of identity is. That means whatever number we put into this equation, it will always work. Again, it could be 0, it could be 500, it could be -3. Any number will work for this problem. Now let's move on to example 6. Solving equations with 2 variables, Delilah pays $16 per month for a gym membership. In addition, she pays $2 per Pilates class. Write an expression with the variables, and then we're going to substitute the values to find the total amount Delilah spent this month if she took 12 Pilates classes. So here's the information that we were given. She has to pay $16 a month just for the membership. And each time she takes a Pilates class, it costs her $2. And to find the total, we're going to use the letter T. So $16 per month using the variable M would be 16M. $2 per Pilates class would be 2C, and that has to equal the total. And when we are finding the total of something, we add it together. So here's your expression. Next, I'm going to substitute what I know. $16, and we're figuring out how much she's going to pay per month. So $16 in 1 month. And it tells us that she took 12 classes that month. So substitute 12. Now we can simplify on the left side, and we have 16 plus 24 equals T. So how much money did she spend for the month? If you add these together, you have $40 equals T. That's the end of this lesson. You will have an assignment that will go with it.